So I'm going to digress a little right now. Why are we talking about signal space? Basically, we're talking about signal space because if all we ever want to do is send binary signals, then there's no reason to talk about this. If everything we wanted to do was purely binary, then basically everything we talk to up until the midterm is sufficient, and that's it. We can all go home. What we want to do here, unfortunately, binary is not the way the world works. Anything practical is in higher order of transmissions than binary. So basically, binary, you're sending one bit at once. Anything practical, you're generally sending 6 or 7 bits at once, or many, many bits at once, in some higher order constellation. So let's digress for a second and talk a bit about M-ary data transmission. Okay, M-ary, so binary, is 2 signals, 1 bit at a time. M-ary, as you might imagine, is M signals, and more than 1 bit at a time. So generally what we're going to do is, in binary we had 2 signals, 1 bit at a time. We could send 0 or 1 if we wanted to. In M-ary we're going to send 0, 1, up to m-1. So there's a total of 2 symbols. Here there's a total of m symbols. So you can very easily imagine how to build up from binary into some power of 2 M-ary. So for example, we can think about 4-ary or 8-ary, which are just, here we would bind together 2 bits at a time. Here we'd bind together 3 bits at a time. So as a quick example of that, we have the string 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, and I want to express this in 4-ary. So this is the way to do this is not unique, but let's just do the obvious way. So in 4-ary, I have 4 symbols that I can send, 0, 1, 2, 3. And what I'm going to do is I'm just going to group together 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1. So what I would get is 1, 0, 3, 2, 2, 3. So there's my string in 4-ary. Does anyone, I mean, I'm just doing the basic conversion here, so I hope that's obvious. Like I said, not unique how to do this. I don't necessarily, for instance, I'm taking this as the least significant bit. If I was taking that as the most significant bit, then I'd have 2, 0, 3, 1, 1, 3. So lots of ways to do that. 8-ary, here I would have 0, 1, up to 7.
Sorry, sir.
Yeah.
How'd you get the 2, 0, 3, 1, 1, 3 again?
That's if this is the most significant bit.
Oh, sorry.
So that would be 1, 0, which is 2.
Yep, got it.
Okay. Okay, 8-ary. So let's go back to my string. in A-ary, how many bits would I be grouping together? 3. We do that. 3. 3. 3. 3. And so I have 4 A-ary letters. What are they? Just with this one significant bit, this one
2.
is 2,
3.
then 3, then
5.
5, sorry, that's just 1, and 3. So, we can immediately see why this might be desirable. So for instance, it takes NB samples to express each symbol. Remember that. So if the time per bit or time per symbol is the same, then what do we have here? Well, basically we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 symbol times that will go into expressing this vector. Down here, piling up 2 symbols at once, if again, each of these takes 1 symbol time, NB samples of whatever sampling rate, now I have only 6, so I've compressed it by a factor of 2. Down here, I have 4, so now I've compressed it by a factor of 3. So in other words, as you go to these higher and higher and higher order modulation, what you're doing is you're increasing the bit rate. You're just cramming more bits into the same amount of time. There are significant penalties, though, as we're going to see in terms of energy. So you need a lot more energy to do this. So if you got tons of energy and not much time, this is how you do it. So that actually describes wired communications quite well. We've got lots of energy that can go down wires, and people want their bits as fast as possible. So in wired communications, you can use very high order constellations like 128 A-ary. Okay, just as you may think, M-ary needs to be some power of 2. Not necessarily. All of these concepts still hold for 3 A-ary, let's say. So I don't think this is really truly practical, but here's a quote practical end quote example of 3 A-ary. So let's say we wanted to transmit something like just all the letters in the English alphabet. We want to transmit words composed of letters in the English alphabet. How many letters are there? 26. In order to express 2 different words, what do we need between those words? Space. Which gives us 27 objects. 27 is 3 to the what power? 3 to the 3. So how many 3 A-ary symbols do we need to express 26 letters plus 1 space? 3. So, I mean, if in binary, if I want to represent, let's say, 8 objects, that's 2 to the 3, so I need 3 bits. In 3 A-ary, in order to get, let's say, 27, basically what I do is take log base m, and that tells me how many symbols I need here. M is 3, so log base 3 of 27 is 3. So for instance, if I want to write hello world,